Hi everyone, welcome to this mentoring session. My name is Xinyu Tan. I'm your mentor for this subject BLDJ1022 building structures. So today in this video, I will explain the equations we learned from week 1 to week 5. Also, I will briefly explain how we're going to use them in the final exam. Before we get started, a little bit about me. My name is Xinyu Tan. This is my email address. Feel free to email me if you have any questions. I'm a final year student doing construction management and property like you guys, and I got an average HDWAM last year. Also, I got 93 for this subject BLDJ1022, so this subject is fairly easy if you just keep practicing. About this subject, I enjoyed my experience when I was studying for this subject. The lecturer, tutor are very helpful, and I could say this might be the easiest ever subject I did so far. So you don't need to write a long report or essay. The only thing you need to do to get a good mark is just memorize some formulas and do your tutorial questions. But I didn't say that you do not need to do anything. You still need to attend your lecture and do tutorial questions, ask any questions you have to lecturer, tutor, mentor. We're all here to help you. Again, the tutorial question is very, very, very important because sometimes you may use the same formula you used in tutorial questions in the final exam, or sometimes you may see the similar questions you saw before in the tutorial questions. So who knows? So today we are going to talk about 13 questions we learned from week 1 to week 5, and let's get started. Week 1, force and vector. All the equations in week 1 are very basic but important, so I need you to memorize all of them. The first equation is the force equation, where the force equals to mass times acceleration. So here I need you to pay attention to the standard unit of these three elements. Why the standard units are important? Because sometimes in the final exam, some question may ask you to use standard unit to kind of express your result. So you need to know what are the standard unit for the elements. For example, the standard unit for force is Newton, for mass is kilogram, and for acceleration is meter per square seconds. Sometimes I saw some students may think the standard unit for mass is gram, which is wrong, and you may lose mark for that. Similarly, another equation is the weight equation. Weight equals to mass times acceleration of gravity. These two formulas are very similar. Actually, they are the same equation, so you could memorize them together. The second equation is Pythagorean theorem, and the third equation is trigonometric ratios. These two equations are very important that you pretty much use them in every single questions. Here, trigonometric ratios can be used to figure out the angle, which is the direction of the force, as well as find out the x component and y component of force. And the Pythagorean theorem can be used to figure out the magnitude of the resultant force. So this is the purpose of why we're using these two formulas. The next equation is Cartesian vector. So it's not, technically speaking, not a equation, but more like a notation. So we just simply put I for the horizontal force and J for the vertical force, and that's it. That's the Cartesian vector notation. This is a very simple sample I got from the lecture tutorial questions. Sorry. So please go back, redo all your tutorial questions, and review your tutorial questions for the final exam, and you'll get a good mark. Finally, the unit conversion table. So this is not an equation, but I think it's very important for you to know that you need to get familiar with this table, because sometimes in some questions, they ask you to do unit conversion. For example, the question 1 from tutorial 1. So you need to know, for example, the kilogram and how to convert kilogram to gram or convert kilometer to meter, etc. Let's move on to week 2, force and vector. The first equation is static equilibrium. So I see static equilibrium formula more like a principle or method when we analyzing questions rather than some just equations. For example, when we say a structure is in equilibrium, we mean all the forces on it and moments on it are balanced, which means it equals to 0. For example, the horizontal force equals to 0, the total vertical force equals to 0, and the total moment equals to 0. Therefore, we get these 3 equations, and we're going to use it to every single static equilibrium question. For example, question 7 from your tutorial question. Here we already know the angle of the force, the weight of this person, and the only thing we need to do is figure out the horizontal force, vertical force, and the moments upon this person. The second equation is moment equation. The moment equals to the force in Newton. So here's the standard form, a standard unit, and times perpendicular distance in meters. Here, the meter is the standard unit. A tip for this equation is that the moment equation is important when to calculate the moment under static equilibrium status. For example, this is a very simple example, but sometimes you may need to apply this formula to a more complicating question in the future, in the final exam. Also very important, the clockwise bending moment should be taken as negative. Sometimes it might be easier for us to kind of identify whether the force is positive or negative, but it might be confusing when we trying to kind of determine whether the bending moment is negative or positive. So the only rule you need to remember is that the clockwise bending moment is negative and vice versa. This is just a conclusion for week 2 equations, and just to help you to memorize all these formula. Week 4, stress. Stress equals to force divided by area, and the unit is Newton per square meter, or you could say Pascal. So this shows or calculates the force per unit area upon which it acts. Sometimes the question may ask you to determine whether this stress is negative or positive. So what are the negative stress or positive stress? Negative or compressive stress is when the negative force pushes on the area which makes the body shorter. For example, imagine when you're compressing a spring to make the spring shorter. That's the compressive stress. And the members are under compressive stress. And tensile stress is when the positive force acts up on the body and makes the body longer. Imagine when you stretching the spring. So the spring is under the tensile stress. It's very easy to understand as long as you kind of have a common sense. So strain is a deformation per unit of the original length. Strain equals to the deformation divided by the original length. It's more like a ratio. So what is deformation? Deformation is a force applied to a body, so its shape and size will change, and this change is called deformation. Therefore, we have positive strain deformation and negative deformation. The negative deformation is when we kind of compressing the object, and the positive deformation is when we kind of stretching the object. And finally, the modulus of elasticity. Modulus of elasticity is a constant shows the stiffness of an object in terms of stress and strain. So it's more like a combination of stress and strain equations. E, which is the modulus of elasticity, equals to stress divided by strain. Again, this is the summarized table of week 4 equations. Week 5, dead load and left load. This is very easy but very important. For the dead load, the only thing you need to do is just to calculate the volume of member. After you calculate that volume of that member, you could get the unit weight of materials from this table. This table may or may not be provided for your exam, so just double check with your tutor or lecturer, and please get familiar with this table, especially some very important material items such as concrete. And you should know the unit weight for concrete is 24 kilonewton per cubic meter. Also, similarly for left load, the left load equals to the area of member times uniformly distributed load. And this table again is used for your uniformly distributed load. Also, still you need to get familiar with this table as well. Finally, we have wind action, or say wind forces. So the equation is that the wind action or wind force equals to the area times wind load pressure. In most cases, the wind load pressure have already been given in the question. For example, in this question, the wind load pressure is 5, and then you need to calculate the area of the building, and then you get the wind action. Similarly, for this question, the wind load pressure have already been given, so you need to calculate the area and then get the wind action. So that's it for this video. I hope it's helpful, and feel free to email me, ask any mentor or tutor for any questions, and good luck for your exam.